Okay, thank you a lot for the introduction. So yeah, my name is Eduardo. You can find me around as Posva, so if you have any question afterwards, I know that sometimes I just walk around and just try to stop me if you have a question, okay? I'm fine, I'm not a mad person. So, as I was said, I'm the creator of the router, also Pinia, and during the time I was creating Pinia, I had a lot of experimenting going on with the refs, reactive, and the whole reactive system of Vue. So that gave me a lot of insights onto how, well, not only exploit that for Pinia's sake, but also how to keep that one single source of truth that we love so much in Vue. And so today, I know that the title of the talk was how to get the most out of your Pinia stores, but that was the generic title before I actually wrote the talk. Now that I have written the talk, I have an actual title that makes more sense, which is Say Alchemy with Pinia. And before that, I just want to make a small show of hands. I think I should be able to see. Who has used Pinia before or already? Okay, so that's, I think, not that much, like maybe less than 50%. And I want to see who has used Pinia before it was stable, like 0.x. Okay, that's like 10 people in the room. Thanks. Oh, thanks for the light. So for the other ones, don't worry, we're going to go through what Pinia is a little bit, but I don't want to disappoint you. We're mostly going through some deep things, I would say, about state management or reactivity, but still very useful overall, even without Pinia. So what is Pinia? Pinia is the successor of Vuex, without really compromising all the developer experience that comes from Vuex. It's compatible with Vue 2 and Vue 3. So this is thanks to Vue.demi, a library by Anfu, another core team member, which makes things so much easier for library maintainers. It's lighter than Vuex. Now, I always say this because the difference is quite good, but in most cases, if you're using Vuex or Pinia, your application is huge already. It's big enough, so you don't need that change. And both are so small that it doesn't change much. It's fully, and we can say automatically, type safe. And by that I mean that you don't need to put too much effort into writing code so that your code is type safe. And this has been one of the main selling points, we can say, of Pinia, but for me it was also one of the main reasons to write Pinia in the first place, because that was a huge pain point when we were using Vuex. And so the library itself is based on the composition API, but you don't need to use the composition API to use Pinia, which is also the idea to have something that works and allows to make a transition between options API and setups, or just stays using the options API if you want as smooth as possible. And on top of that, it has also a few, let's say, official libraries under the Pinia organization that you can use. So one of them is a testing library, so that's for mocking stores. That makes things much easier when testing. Also a Nux module, and maybe any others to come, like ORM. I've talked about this with Kia, but we haven't done it yet. I mean, he hasn't done it yet. I'm probably not going to write the code for that one. I'm just going to learn the name of the package. And so if we want to do the quick summary of how do you change, what is the transition, what changes between the code in Vuex and Pinia. This is a sample for Vuex4. So Vuex4 is for Vue 3, and you have this function createStore that creates a store instance, and it accepts a state. So that will be a function that returns the initial state of your store. You have mutations, which are functions to change the state. Getters, which are just computer properties. And then you have actions, which are methods that allows you, so they are methods, except they have specific parameters. And so you basically have two rules when you're doing Vuex. It's that you can only change the state in mutations, and second, you have to shout if you want to change it. That's what we have every time things in uppercase letters. Now, the other thing is mutations have to be synchronous, and only actions can be asynchronous. And last but not least, we have, at the very end, the last line, you have to use the store as an application plugin to tell Vue that we're using Vuex. Now, if we change that into Pinia, there isn't much that change, except you no longer have to shout to change the state. You can just do it. And you use a function that is not creating a store, is defining a store. So the difference is that that function is going to return another function that we call to get the actual store. The reason we do this is to handle all the different ways we use the store and to have an out-of-the-box dynamic module registrations like we have in UX. Except you don't even have to think about it. It just happens all the time with Pinia. So we have a state. Sorry, I swallowed a little bit on the other side. You have the state that returns the initial state, getters, computed, and the actions no longer have these fixed parameters, and you can use these to access the state or getters or any other action you want. Now, the last part is the interesting part I want to talk about. It's instead of using the function use store, I call that one, as a plugin, we have a create Pinia function that that is going to gives us a plugin that we use. So that create Pinia function creates the Pinia instance, we call, and it's what gives its name to the library. And it's also supposed to be a transform word for the pineapple word in Spanish. Now, I know what you're going to say, Eduardo, what are you doing? We only do French words in a Vue ecosystem. What the hell? And also, ananas is the most common translation of the pineapple word. The only exception, I think, is abacaxi in Portuguese, and piña in two languages, I think, one of them being Spanish. So because it's a mostly common translation of pineapple, it was already taken on NPM, as you can expect, because we like to use whatever names we have to do whatever.js in this ecosystem. But contrary to popular belief, it's not just a random name. Okay, so Pinia is what brings together all the stores, just like a pineapple brings together multiple flowers after they blossom into one single fruit. Okay, so it's really something that makes sense. It's not just a random name. And so it all starts when you call these abuse Pinia. So you're passing the Pinia instance as a plugin, but it's a little bit more than that. And so I want to dive into what does the Pinia instance really do. And so if you look at the Pinia instance, you're going to notice that we have two things. The first thing is a function, use. So it's exactly like app.use. It's for plugins, but this time for Pinia plugins. And the second thing is a state. And this state is just a ref of an object, initially empty, but it gets populated after you call some stores. And that state is called inside, or rather is instantiated inside what we call an fx scope. Now, to explain fx scope, we can talk about components real quick. When you have a component that is mounted, it's going to create its own fx scope. And that fx scope is going to collect all the reactivity variables, the watchers, the computed, and everything under its umbrella. And when the component is unmounted, the fx scope is disposed, and all the reactive variables go away and get freed. So this is the same for Pinia, except it never disappears. It's always there for your application to run. So your reactive variables are always working, right? And so the first thing that we notice is that Pinia is going to hold the state for us, okay? The stores are never going to hold the state by themselves. They're going to transfer that to the Pinia instance. And so you can access the state at any time as Pinia.state.value. And what happens is that the first time you call the use something store in your application is going to put the initial state into the store using the ID of the store as the key. So here, the ID will be off. It will be added at whatever you define inside state. Then we call another store that's going to add another object. And so as we go through the application, or rather, as the user navigates through the application, the store keeps growing as it's needed. So we end up with something that looks like this, with auth, cart, et cetera, et cetera. Now, there is also a connection done here, because when you use a store, you can access through the store instance the whole state of that store through $state. Now, that variable is actually just a getter to access the store in Pinia. It's not another variable that is connected, it's just the same one. And we actually have three different ways of accessing the store. Through the Pinia instance, through the $state on the store instance and directly through the store instance, as we could expect, like the other getters and the action, just because it's more comfortable. And so any of these variables is going to yield the same result, of course. And also, if you write to any of these variables, you're also going to write to the 3 of them. In fact, you're not writing to the 3 of them, you're only writing to the Pinia state, because there is only, and this is important, there is only one source of truth. There are not 3 of them who are connected, okay? There are only one single source of truth, and we have different properties connected to that single source of truth. So, and I know this might look a little bit simple for some of you, but when we're doing a define store and we have this useStore function, and we have the state function that we define, and we instantiate the store, effectively what we're doing at some point is passing that object to the Pinia state, okay? And what happens later is that we are getting a ref out of the state. So toRef is a function from Vue, composition API, that gives you a ref to a reactive object. So if you have something that is reactive, you can get a ref to any part of the object, and it will be connected. It will be like the same thing. If one of them changes, the other one changes as well, all right? So you only have one single source of truth, which is the important part. And so one thing you notice, though, is we don't have to write auth_store.user.value.login. We don't have to read that ref as a normal ref. We just read the property or write to the property without using the .value. Now, this thing is what we call ref unwrapping. And this behavior is going to become very interesting because what happens is that auth_store is actually a reactive object. So any ref passed inside is going to get unwrapped. So when we are creating a reactive object, so that's going to be with ref or reactive. Both are reactive objects, okay? Any ref passed inside at any level of that object gets automatically unwrapped, okay? So if I just put a ref inside of an object, you don't need to write the .value anywhere. And type is going to be type safe anyway, so you're not going to make the mistake if you have at least some IDE hints. So you can avoid, by the way, this behavior if you want with shallow ref and shallow reactive, but that's beyond the scope of the talk. What I focus is on this part here, the ref. Now, the thing is, you should never do something like this, okay? Never write a ref inside of a reactive object because there is no point in doing so. That's just the same as writing the string Alice there. It won't change anything. But what's interesting is not refs themselves, but refs with other behaviors attached to them. And so I'm thinking about composables. So composables are just functions that return have a stateful return. So we can have a ref, we can have read-only properties, anything we want. Sometimes we have watchers. And this is the most common use case that I see. I don't know how many times I've seen these questions in discussions or the Discord server. How do I persist my state for the store? It's like the main point of the store is persisting the state, although it isn't really. But the point is, you can put a use local storage here, which is a composition function from Vue use, which is a library of composables. But basically what it does is it gives you a ref that is going to read from the local storage, but also write to local storage. It kind of transfers the source of truth to the local storage. So you just interact with the ref in a natural way, abstracting where it is stored. It becomes an implementation detail you don't really need to think about. And so, of course, the thing is, if I'm showing you this code, is because it means that we can call that composable inside of the state function when we define a store. And so it doesn't limit ourselves to use local storage. Any writable composable, so if you have a composable that returns a writable source of truth, like a ref, for example, use color mode, use route hash, are going to return variables that we can read and write to. Even though they are refs, we can put them inside of the state, and they're going to get unwrapped. So the actual behavior that might be interesting for us becomes an implementation detail we don't need to care about anymore at all, because it's just going to work out of the box. Now, the thing is, these versions are always going to work out of the box. But if you have read-only state, it's going to be a little bit different. The same goes for functions, okay? So these are two different composables, that don't return writable state. One returns read-only property, so that's going to be more like a computed property. And then the other one is going to return functions, so that's more like an action, right? And while it's not possible to use them in this scenario, I'm going to show later how to use them. So going back to the ref unwrapping, there is something I need to talk a little bit more about. And this is when does this not work? So it works most of the time. And by most of the time, I mean client-side rendering, because most of the people are, by the questions I get everywhere in Discord and everything, they are doing client-side rendering. So if you're doing client-side rendering, you're done. You don't need to do anything else, okay? Everything works. However, if you're doing server-side rendering or SSG, server-side generation, you have a little problem. The problem is the state function is only called once in the whole application. It's only called the first time we instantiate the store. So you may think, but what is the problem here? Well, the problem is how does any application, relates to the client-side rendering, also known as CSR, and server-side rendering, also known as SSR. Sorry. So we're going to start by talking about the client-side rendering, because it's the most common use case. So we start with an empty state, then we call any use store, and that's going to instantiate the initial state that becomes reactive because we have it in a ref. Now, that's all good, but when we do server-side rendering, we start also with an empty object, and we do the same things. We create some stores, we populate the state, and all good. What happens, and what's interesting, is when the page comes back to the client on the browser. Because when we do that, we have the client-side rendering again. Except on the server, the state was already executed. It was already instantiated once. So we're not going to do that again on the client, okay? So we don't get an empty object here. We get the object from the server. So when we call use of store, that part that we had before that was creating the composable for us is no longer called. So we no longer have that composable creating all the watchers, connecting all with the event listeners to the to the window. And that becomes a problem. Because, just to show again the function, that function is not really called anymore. It becomes just the string, all right? Because the server is going to give us Alice probably because there is no local storage. And fortunately for us, Vue is going to make the use local storage function work on the server as well. Because, by the way, I didn't tell this because it goes, again, beyond the scope of the talk. But some composables require a little bit more work if you want to make them work on SSR, okay? You have to check if you have a current instance. You have to check if there is a window object that you can rely on. And if you ever want to learn more about that, what I recommend you is to check the source code of Vue composable, of Vue, sorry. It's very comfortable because if you go into the documentation on any of the functions you have, at the very bottom, you have a source link, so you can just click and it goes right into the GitHub repository and you can just check the source code from there. And honestly, I always say this in my workshops, this is a very, very easy way to learn how to write better composables and how to get the most out of this reactivity system in Vue.js, okay? It's going to make your code way more maintainable because you're going to be able to keep one source of truth and to move the logic that is not always related to the business logic you're building your application, to move that logic that is just technical details or things that are not business related into the composable. And that's a huge deal when you're writing a lot of code. So what do we need to make this version work on server-side rendering? We need an extra function that is called hydrate that is going to revive, kind of, that login property. Is going to just create the watchers, the event listeners on the client side. So this hydrate function is called only if there is an initial state the first time the store is created. And that means basically when you render your application on the server and on the client, it goes back and you need to use it. Now, if we recap, so it's going to replace that setting the state, that state being set by useStore, is going to be replaced by the hydrate function. And if we recap the whole thing, we have on SSR, you have initial state, you call all the use stores, we have the state at the end, and then it's going to be sent into the client. We start with that state, we call useStore, we skip calling the state function, and then we have the iterate function, adding the little bits that we were missing from the state function again. So, then I want to talk a little bit more about what more we can do. So, as I was saying before, this is only for writable state. Okay, the use local storage returns a ref you can write and read. So it is a state. However, that's not always the case with composables. And so to use the other versions, we have to talk about another kind of store. We have the option stores is what we know here. So we have options, pretty much like the options API. And then we have the setup stores. Not the definitive name, to be honest, but whatever. I don't want to call it composition API stores. That's way too long. And then we're just going to say CAS. It's going to become weird. Setup stores are just stores that are defined with a function that are pretty much just the setup function that we have in components for the composition API. So in this case, we don't have multiple properties like a state, getters, and everything. We just have one function, and that's it. And that function has to create refs or reactive objects if we want state, and return them if we want them as well. And then it's going to create computed for getters, and then it's going to create functions for actions. Okay, so it's going to look something like this. And at the end, you return everything you want to expose, and you can keep anything you want to keep private, inside the function without returning it. All right. Now, here is the interesting thing. Because we have just one function that defines everything, we cannot just not call it. We have to call it in all the cases. So we have to call it on the server and on the client. So we need to hint Pinia that the local storage one shouldn't be hydrated. We shouldn't copy the value that comes from the server. We should just use the composable as is. All right? So we have this Skype hydrate function that just adds a small flag. And what happens behind the scene is that normally, when we're on the client, after the server has rendered the application, the store is going to go through all the different properties that have been put into the initial state. And it's going to take the values from the initial state and put them into the store state. And more exactly, into the ref that we return in the function. You see there the user ref we return? That's what we're changing. User.value equals initial state.user. Now, and then what we do is we transfer that ref that was created by the store into the Pinia state so that we have one single source of truth. And that closes the loop. And the thing is, with the skip hydrate, we are skipping the first line, okay? The user.value equals something that's no longer happening. That's what we avoid. And so if we look again at the use eyedropper, for example, what does it return? It has a plain Boolean is supported, it has a function open, and it has a writable ref, which is going to be RGB hex, so just a color. Where do we need to use the Skype hydrate function? Because it becomes a bit confusing. Should we use it in everything, or what exactly? So I just wrote down the code, so I extracted the 3 properties. I can return them inside of the store. So among these 3, only the last color is going to become a state, because the is supported is just a constant. It's never going to evolve, so there is no reason to put that into a state. Also, only refs and reactive properties are going to be put into the state. So what's interesting is that we can stack these refs together. So we can pass the sRGB hex ref to the use local storage. Now, of course, the composable handles this, right? It takes care of using a ref, but basically the important part is if you pass a ref to a ref, it doesn't create a new ref, it just uses the ref, which may sound a little bit confusing, but written is way less confusing, I swear. And so in this scenario, because the use local storage relies on what the browser is seeing and doesn't care at all about the server response on the initial value for the last color, in this case, we want to use a skip hydrate, okay? But if we were using only the use a dropper thing, which, by the way, I didn't explain, but it's just a color picker that picks on the screen on the colors, and it is not supported by many browsers, by the way. It just looks cool. But it returns an action, and that's what I wanted. So if we were using only the use a dropper, we wouldn't need a skip hydrate, because we don't care most of the time if we hydrate from the server-side response or not, because there is not a new value in the browser context that is interesting for us, and that could get overridden by what the server sent. But if we use the local storage, then we need to make sure that the one in the browser prevails, and the server one is just ignored. So what you really need is not to use keep hydrate on every single ref or anything, just on the ones that you want to avoid setting the value from the initial state, and only on SSR, of course. So that's why I'm also doing at the bottom this time. I'm not doing it right on the variable declaration, because you can also just group everything down. It really adds just a flag, so it returns the same parameter that is passed, and it doesn't create a copy or anything. Okay, I want to summarize everything up with a small summary. In option stores, what you can do is you can use any basic composition API instead state. By basic, I mean returns writable state. And then you can use hydrate for any of them if you need to revive some of the behavior. Most of the time, you're going to need to use hydrate, okay? I think there are little exceptions, so try to use hydrate most of the time. Then the setup stores, on the other hand, you can use any composable, like you do in a setup, because that's the point. It automatically tells apart the state from actions from getters based on the type of the property. And then you can use escape hydrate if you want to ignore the values that come from the server. That will be the summary. And I hope it didn't get too deep, and also that it was deep enough for people who knew. So I want to finish just by saying thank you to the sponsors that sponsor my open source work, because especially the companies. There are not that many companies, especially because they still need more funding to keep working full-time on open source. I don't work full-time on open source. I cannot. So if you want to sponsor or anything and you want to reach out, just know that I'm a consultant too, so we can probably find things to work that out. And I want to finish by telling you thank you. Enjoy the rest of the conference.